Okay, good morning. Welcome to
SuperMath153.
SuperMath153. So we're doing the review section in Power of a Point, and this is one of the review problems, or it's based on one of the review problems. You have a point outside of the circle, and Power of a Point talks about for any chord from P, PA times PB is equal. Okay, no matter how I shift that chord. It's a very natural question to ask is what is it equal to? And what you're going to show here is that that product, PA times PB, ends up being equal to PO squared. In other words, the distance from P to the center of the circle, minus R squared. Which is very interesting.
Well,
so how are we going to show this?
Well, from the regular power of a point theorem, I'm just going to call this point X and this point Y.
Okay.
We know that PA times PB that.
Racers on a chair there.
PA times PB equals PX times PY.
Okay.
We don't know what PX is, but we know what PY is.
What's PY?
PY is it's PX plus 2R.
Okay.
So maybe we could use this to help us. We have our PA times PB.
We have PA times PB. Yeah. What else do you have?
We also have. We don't have a PO.
Okay, we don't have a PO.
But we could say this is. We could say this is PO plus R.
Well, okay. So we're trying to get another side of the equation with POs and Rs in it. And right now you have PXs in it. So yeah, so it would be good to see if we could get rid of those PXs and instead change them into POs.
PX equals PO minus R.
Right, there you go. PX equals PO minus R.
So we could say PA times PB equals PO minus R times PO minus R plus 2R, which you could just say is PO plus R. Well, now we have a difference of squares.
A difference of?
Squares.
A difference of?
PA
squared
times PB is PO squared minus R squared.
How interesting. So this is a very important idea. You have a product that's equal to a constant. No matter what line I draw here, if I draw it like this, the product of P, I'll call this A prime and B prime. PA times PB equals PA prime times PB prime. And that product, it turns out, is that constant is not just some random number. It turns out to be the distance from P to the center of the circle squared minus the radius squared. Now, notice that this is always positive. When P is outside of the circle, the distance from P to the center of the circle is always bigger than the radius.
Yeah.
Right? So now the next question to ask might be what happens when P is inside of the circle, because when P is inside of the circle,
you have a different power.
This is going to be this expression, the distance from P to the center of the circle squared minus the radius squared, that would be negative. So the formula must change when you're inside of the circle. You want to see if we can figure it out?
Alright.
Alright, let's all
Maybe part B.
Let's do part B. See if we have time first.